For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. Okay, looks like we are live, guys. There's just a slight lag on my end there, but looks like we're good now. People in the audience can let me know if audio and video are good. So we are live for this incredibly exciting debate. Tonight we are debating the age of the earth. Does the evidence point to a young earth or an old earth? And we've got two very, very seasoned debaters here, both Dr. Kent Hovind and Jordan from Reason to Doubt podcast are no strangers to debates. They've been here numerous times. So I want to thank them both for giving us their time for this incredibly important debate. I'm extremely excited, as I know the audience is as well. Why don't we hand it over to the debaters just for a quick introduction into themselves, kind of break the ice, how their channel's coming along, what they're doing over at their ministry or podcast in the case of Jordan. Why don't we start with Dr. Hovind? Thank you so much for being here. Oh, I think I'm not getting any audio from Kent's side.
One more time, Doug. One more time.
One more time.
There we go.
There we go.
Okay, testing. Yes. Hello. My name is still Kent Hovind. My name's still Kent Hovind. Has been for a long time. I was a high school science and math teacher 15 years. I've been a Baptist preacher 46 years, and we have a Christian camp in Lenox, Alabama, called Dinosaur Adventureland, straight north of Pensacola, 70 miles. come on out and pay us a visit. We believe the Bible is true. God made everything in 6 days, dinosaurs, stars, everything. And we believe the evolution theory being taught in schools is a violation of the law to teach a religion in a public school, and they're doing it anyway. We think it's the dumbest and most dangerous religion in the history of the planet. I believe the earth is about 6,000 years old, like Jesus said. Okay?
Awesome. Well, thank you, Dr. Hovind. Thanks for being here. I'm really excited for this. Let's hand it over to Jordan. Thanks for being here. Thanks for giving us your time for tonight.
Yeah, thanks for having me. Like you said, my name is Jordan. I'm a mechanical and nuclear engineer. Once upon a time, I was a young Earth creationist. So I came up watching Dr. Hovind's videos, like most young Earth creationists. Eventually, I realized that the evidence didn't support the beliefs I had, so I changed my beliefs. It's as simple as that. Now that I'm a godless atheist, I run the Reason to Doubt podcast on skepticism. We're also on YouTube now. We mirror our episodes there. We tackle everything from young Earth creationism and whether the Gospels are historical to alien abductions. So try to have a good time. So if that interests you, come and check us out.
Awesome. Well, thank you so much, Jordan. Thanks to the both of you. I'm going to go over the format for tonight briefly, and then we'll hand it over to Jordan for his opening statement. So it's going to be an easygoing debate, a lot of fun. We're going to be starting with 10-minute opening statements, starting with Jordan, followed by 5-minute uninterrupted rebuttals, and then an equally timed cordial discussion, focusing on one topic at a time, ending with an audience Q&A. So please make sure you're tagging me at Standing for Truth. That way I can see it in the midst of the lively chat. We got a big audience tonight. So without further ado, enough from me. Let's hand it over to Jordan. You've got 10 minutes. I'll give you a minute warning if you'd like before you're about to run out of time. And go ahead. The floor is yours, Jordan.
All right, can you see my screen? Oh, that's weird. Is it flickering for you? Is it flickering for you, SFT?
It is now, yeah. Yeah, now that I added it to...
Yeah, we try refreshing it. If not, then I'll switch to one monitor and see if that works.
All right, there it is. Let me try it again.
You good now?
No more flicker.
Awesome.
It's evolved, Jordan, so you're good to go.
It's a miracle.
It's a miracle, yeah.
So, on the question of the age of the Earth, I share the position of virtually every expert in every relevant field. The Earth is 4.5 billion years old, far older than the 6,000 years posited by creationists. There are many lines of evidence for this, but I'm going to focus on just two: radiometric dating and Big Bang cosmology. In other words, I'm going to try science. First up, radiometric dating. In nature, there are some unstable elements that will decay, becoming a new isotope and emitting radiation. The original isotope is called the parent, while the new one is called the daughter. The rate at which this happens is called the half-life. This half-life can be measured, so if we compare the amount of parent to daughter in any sample, we can infer its age. Think of it like pouring water from a pitcher into a cup. If we know how fast the water flows, we can look at how much water is in the cup versus how much is in the pitcher and determine how long the water's been pouring. This process is called radiometric dating. There are many different dating methods, but they all paint a consistent picture. The Earth is not thousands of years old. In fact, it's billions of years old. Now, in the past, Kent has said that radiometric dating is not scientific because it's based on unscientific assumptions that can't be confirmed. Namely, one, there was no daughter isotope to start with, which would be like the cup already having water in it, if there was some to start with. Number two, the sample has been isolated for billions of years, so nobody came along and added or removed water. And the half-life has been constant throughout time, or the water's been poured at a steady rate. In fact, these aren't untestable assumptions that we should take on faith. On the contrary, we can test for violations of these assumptions, and sometimes we can even eliminate them completely. So let's start with the first assumption and take this imaginary sample. When the rock was formed, it had some daughter isotope already in there. This is exactly the scenario we're told is a problem. Some of the daughter isotope wasn't produced by decay, so if we date the rock today, it'll look older than it actually is. But our sample also has a third isotope that is stable, meaning it doesn't decay and it isn't produced. It'll stay constant the whole time. When the rock was formed, there was some ratio of daughter isotope to stable isotope. We don't know what that ratio was, but it was some number. Then time passed, and today we can observe some other ratio of daughter isotope to stable isotope. So we have a few ratios, some that we know, some that we don't. Unfortunately, here's where the math comes in, but all this equation is saying is that the amount of daughter isotope today equals the original amount that was there when the rock formed, plus whatever you've got later from radioactive decay, and then you divide all of that by the amount of stable isotope, which isn't changing over time. Remember, it's not decaying and it isn't produced. There are three important things to notice about this formula. First, the equation is in a form you may remember from middle school algebra, y equals mx plus b, the equation for a line. Second, y and x are things we can measure today. Y is the ratio of the daughter isotope to the stable isotope today, and x is the ratio of the parent isotope to the stable isotope today. Third, and most excitingly, the slope, m, tells us how much parent has decayed, so we can use that to calculate the age. If you plot those x and y values, you get a graph called an isochron that looks like this. The slope of the resulting line gives you the age of our sample, and we got that without needing to know anything about how much daughter isotope was there when the rock was formed. So that's one assumption down. Let's look at the second one. How do you know the sample was isolated? For this one, let's look at uranium lead dating. What you see on the screen is called a zircon. It's a crystal that has uranium in it when it forms. That uranium decays into lead. The cool thing about uranium lead dating is that you have two different kinds of uranium that produce two different kinds of lead. So you have two clocks for the price of one. In a perfect world where the crystal was undisturbed through its entire life, these clocks would agree. The plot of that agreement is called a concordia. But what if it was disturbed? How would we know? Well, all isotopes of an element are chemically identical. So any process that removes one isotope will remove all of them at the same rate, but they don't accumulate at the same rate. So because they'd be removed at one rate but accumulated at a different rate, that would cause the clocks to disagree. This is called discordia. Thus, if the two clocks show the same age, it is extremely unlikely to have happened by chance, and you can be very confident your crystal was undisturbed. If the clocks disagree, you know the crystal lost some lead along the way. So that's two assumptions down, one more to go. How do we know the half-life has been constant for billions of years? I mean, we've only been measuring it for 100 years. To illustrate why this isn't a concern, I'm going to briefly talk about the coolest thing that has ever happened, a naturally occurring nuclear reactor. For a nuclear reactor to work, you need 3% enriched uranium concentrated in a spot with water. Once you have that, boom, you get fission. Today, natural uranium is only about 0.7% enriched, and it's getting less enriched over time as the uranium decays. This means if you dial the clock back, it would be more enriched in the past. It turns out that if you went back about 2 billion years, natural uranium would be at the 3% enrichment you'd need for sustained nuclear fission. If you got that enriched uranium in the right spot along with water, you'd have a nuclear reactor. And it turns out that's exactly what happened at the Oklo mine in Africa. At that mine, they found uranium that had undergone fission, it was depleted, along with fission products, which are elements that are only produced in the observed quantities in fission reactors. It's the only way to get them that way. The evidence of this fossilized reactor is so clear that even people like Answers in Genesis don't deny it. But, of course, it poses a problem for creationists. You need 2 billion years to enrich the natural uranium enough for fission, but we've only got 6,000 years to do it in, if the young Earth model is correct. So to fix this and other observations like radiometric dating, some creationists have come up with a solution. What if it went faster? If the uranium decayed faster, it would reach 3% enrichment faster, even within 6,000 years. Problem solved. Unfortunately, lower half-life means more radioactivity by definition. To compress billions of years of decay into just a few years, you'd have to lower the half-life by a lot, and thus increase the radiation by a lot. How much? Well, you may not know this, but the food you eat and the water you drink are radioactive. If the compressed nuclear decay happened during Noah's flood, for instance, Noah and his crew would be receiving, from just the food and water alone, 19 lethal doses of radiation every hour straight to their internal organs. That's bad. But even as bad as that is, just wait, there's more. See, when radioisotopes decay, some of their radiation is in the form of energy, i.e. heat. Today, deep below the Earth's crust, heat is generated by the decay of U-238 and thorium-232. The CAMLAND project measured neutrino emissions in order to estimate the amount of that decay. Neutrinos are emitted when those isotopes decay. They found it to be about 20 terawatts, about half of all geothermal heat. More radioactivity means more heat. So if we accelerate the decay in order to fit the young Earth model, things are going to get hot. To find out how hot, I did some calculations using the lower bound of the CAMLAND data. So to give you some a sense of scale, here's the heat flux, meaning heat emitted per square meter, of some sources you might be familiar with. A person walking around emits about 100 watts per meter squared, like your stovetop emits about 28,000. A burning surface, like some wood or house or whatever, emits about 200,000. Here's those everyday things compared to the sun. Now, obviously, the sun is pretty darn hot. Unfortunately for Noah and his brave crew, the sun can't hold a candle to the Earth under accelerated decay. That's right. If you accelerate the decay to the amount needed by the young Earth creationist model, the Earth would emit more heat per unit area than the sun. Now, I don't know about you, but I am personally interested to hear how anything survived on the radioactive ball of superheated death that is predicted by the young Earth model. One would think that melting the entire Earth would have left some kind of evidence behind. And so we've laid the last objection to radiometric dating to rest. These assumptions are not unscientific. In fact, they are testable and often completely avoidable. Speaking of balls of radioactive death, let's look at the stars. Cosmologists tell us that the universe is about 13.8 billion years old. Now, there's a lot of physics behind the Big Bang model. It's a prediction of general relativity, for example, one of Einstein's most famous theories. Unfortunately, I'm almost out of time, so I'll have to look at just two pieces of evidence, Hubble's law and the observed ages of stars. In 1929, Edwin Hubble wanted to see how stars were moving relative to us. To do this, he measured the shifting of their frequency, just like how the sound of a vehicle is lower frequency when it's moving away. Light that's moving away from you, or the source is moving away from you, is redshifted. Much to Hubble's surprise, almost everything he saw was redshifted. Not only is everything moving away from us, but the further away something is, the faster it's moving. This is incontrovertible evidence that the universe is expanding. Now, if everything is moving away from each other now, if you wind the clock back, it was closer together in the past. You can plug that in some complicated physics. You'll need some calculus because the rate isn't constant, but if you plug all that math in, you can get an answer for the age of the Earth. That's a range. That range is 12 to 14 billion years. So lastly, we can look at the stars themselves. The larger a star is, the faster it burns through its nuclear fuel. Smaller stars burn slower and dimmer, bigger stars hotter and brighter. By seeing how bright or dim stars of certain masses are, we can determine their age. Looking out in the universe, the oldest cluster we've seen so far, M68, is about 12.2 billion years old. The universe clearly can't be any younger than its oldest star, so that puts a lower limit on the universe's age of 12 billion years. So, in conclusion, I've merely scratched the surface of the tons of evidence that the universe is very old indeed. What's important here to remember is that we have different methods from different fields based on different observations, and all of them are consistent with one another. They didn't have to agree. If God created the universe 6,000 years old, he could have very easily made these clocks disagree with each other. All of these different observations from different fields agree because they are correct.
All right. Thanks, Jordan. Just on time, 10 minutes. And Dr. Hovind, you're muted, but whenever you're ready, the floor is yours. You've got 10 minutes for your opening. I'll put you full screen.
All right. Well, thank you, sir. I appreciate you coming back, Jordan. We will get you converted back before it's over with. Talk about the age of the Earth. We talked about thermodynamics. First law of thermodynamics says matter or energy, either one, cannot be created or destroyed. So your whole argument, you have to understand, you're bypassing completely the initial obvious question, where did matter come from? Where did energy come from? To say there was a big bang raises the obvious question, what banged? Where did it bang? Where did it come from? Where did time, energy, and matter come from? You evolutionists completely avoid that. You say, well, there was a dot of near nothing, a tiny dot that exploded. Wait a minute. You couldn't squeeze a bowling ball into a dot that size, let alone the whole universe and the Pacific Ocean in there. So you're just absolute insanity to believe that the Big Bang created time, space, and matter. You don't have an answer. You don't have a starting point for any of this argument. If you can't find where did matter come from, where did energy come from, first law says matter and energy cannot be created or destroyed. Your theory goes directly against the first law of science. It can't be. There's only two choices. Somebody made the world or the world made itself. There's a few weirdos out there that say we're not really here at all. We just think we're here. Okay, well, you can ignore those folks. The Bible says in 10 words, in the beginning, God created the heaven and the earth. I've chose to believe that. It says 17 times in the Bible that God stretched out the heavens. Why would all the red shifts appear to earth? Jordan, if we're not in the center of the universe, the fact that we are the center of God's attention, all the stars show a red shift. They're all receding from us. we must be important. We would be part of this mass movement, and if it was not the center. Anyway, but the Bible says God stretched out the heavens. The redshift is not a problem for the creationist. God made the earth first, and then he made the stars and stretched them out into place. So Adam and Eve would see the taillights of the stars as they're receding. They could be billions of light years away and still be 6,000 years old if the God stretched out the heavens. Anyway, humanists regard the universe as self-existing and not created. Well, how? They talk about the Big Bang. And matter and energy can't be created or destroyed. So we cover this in great detail in video number 1 of my creation seminar series. The first law of thermodynamics from livescience.com a few minutes ago states that heat is a form of energy and thermodynamic process are subject to the principle of conservation of energy. This means heat energy cannot be created or destroyed. In your model for radioactive decay, Jordan, you talked about the heat inside the earth. Whoa. Where did this energy come from? Where did the matter come from? Where did these radioactive elements come from? All the radioactive decay we're aware of is a decaying process, declining. How do you get up from hydrogen to uranium? You want to start with uranium and talk about it going down, or thorium, or any of those elements like that. How do you get from, where do they come from? There's no, you guys offer no answer to that. Okay, from esterelmountain.edu. Energy exists in many forms: heat, light, energy, and electrical. The first law of thermodynamics states energy is always conserved. It cannot be created or destroyed. So where did it come from? Where did it start? Here's from NASA a few minutes ago. The first law of thermodynamics. There is heat transfer, but it's not creation of heat or matter. Limitation of the first law of thermodynamics. Energy can neither be created nor destroyed. It can be converted from one to another. And when it is, things are lost. They lose energy. Everything's cooling down. God said, Lord, in the beginning, thou hast laid the foundation of the earth. The heavens are the works of thy hands. God made them. First law. God just did it. Where did God come from? That's a whole different argument. But I've chosen by faith to believe in the beginning God. You've chosen by faith to believe in the beginning a dot. You want to take that to Judgment Day? You go ahead. I think you're going to be really embarrassed, but that's okay. This says, they shall perish. They shall wax old. There's a second law of thermodynamics. Everything's falling apart. Of old, thou hast laid the foundation of the earth, the heavens, and the work of thy hands. They shall perish. So I believe most people, thinking people today, believe it is dumb to worship a dot of nothing that exploded into a universe of ordered life. You said you believe the Big Bang, Jordan. Now think for a minute. If this dot of nothing banged and the matter went out 13.72 or whatever number you're using today, billion years into space, was the matter accelerating faster than light? Like trillions of times faster than light? How do you accelerate matter trillions of times faster than light so that it can grow into these ginormous stars that make our Earth look like a dot on an ocean? So I think it is absolutely insane to believe the Big Bang theory that a dot of near nothing, a trillionth the diameter of a proton is what many websites say. That's pretty tiny, okay? The current universe came into existence 14 billion years ago. Now hold it. That's from an evolution textbook used at a university, I forget what. Oh, this is from Fukuyama, I figured. It's not billions of years old. You can't accelerate matter faster than light. You can't accelerate light faster than light. 13.772 billion years ago, the estimated age of the universe, with an uncertainty of 59 million years. Okay. Most thinking people think that's dumb to worship time, space, and matter. And that's what you guys do. You give the attributes of God to time, space, and matter. Time can create things. Time can change an amoeba into an elephant. Well, you can believe that if you want, but that's not science. You don't have any science on your side for the Big Bang. 13.8 billion years ago. Scientists are undecided if it means the universe began from a singularity. That's a code word for a tiny dot, okay? Or that current knowledge is insufficient to describe the universe. They give two choices. Did it begin as a dot, or we don't have enough? There's a third choice. God did it. It's like me asking, which is correct? 2 + 2 is 5 or 2 + 2 is 6? I give you two wrong options, and you got to pick one. That's what they give the kids all the time in school. Did evolution happen quickly or did evolution happen slowly? There's another choice. It didn't happen. They don't even offer that option. Anyway, 13.8 billion years ago. What happened before the Big Bang? You guy did a website on that. The LPP fusion did one of the scientific evidence against the Big Bang. I won't bore you with all the details. You can look up that website and read it for yourself. There are lots of problems, and not everybody, you said at the beginning, every expert in every relevant field believes like you believe. You are dreaming, son. That is not correct, okay? You may have a lot of people that believe that. I understand. You might have a majority that believe that. But it is incorrect to claim that every expert in every relative field believes like you do. You're dreaming. Second law is the measure of entropy. Things are falling apart. All systems gain entropy over time. Things are falling apart. First law says energy is always conserved. It can't be created or destroyed, but you guys violate that. And the law of entropy says everything's going down, but you guys violate that. You want to go from a dot of nothing to a universe with bazillions of stars out there, and one of them has a planet going around with unbelievable complex life forms, and you think all that fit in a dot. I cannot believe you have a channel, Reasons to Doubt God in favor of that? You would give up God to believe in a dot. Where have you been, Jordan? I don't know. Anyway, second law of thermodynamics, you can read all about that. Everything tends toward disorder. Give it enough time, it'll fall apart. Second law of thermodynamics is demonstrated every day when you wake up. Look at your hairdo when you wake up in the morning. It's not getting better. Here is Sue at 20. Here she is at 90. Okay? Things do not improve with time. Here she is at 3,000, a pile of ashes, okay? So the second law says the universe is constantly getting more disorderly. It's falling apart. You can read all about the second law. All you have to do is nothing, and everything deteriorates, collapses, breaks down, wears out all by itself. That's what the second law is all about. Second law says entropy increases, and you guys want to violate that. You want to create stars out of a dot. Where did this matter come from? And we see the decay of elements, radioactive decay, carbon dating, rubidium, strontium, lead-208, lead-206, carbon-13, carbon-14. I understand all that. And you give examples of it decay. Jordan, stop and think. That is the opposite of improving. That's decaying. How do you get it higher to begin with? You're not getting it. Arthur Eddington, English astronomer, 20th century, did his work on astrophysics, talked about the laws of entropy. If things are falling apart, there's a heat loss from a building, there's a heat loss from the earth. Humans probably evolved from bacteria 4 billion years ago. Evolution, the whole theory violates both of those. Now, I know I got 1 minute. You guys have to have billions of years to turn your dot into a human. I know that. If you take away billions of years, your whole religion collapses in one fell stroke. All it would take is one scientific evidence that to prove the earth is not billions of years old. Just one. And your whole case collapses in a heap. And I can do that with plenty of scientific evidences. Watch my video number 1, The Age of the Earth, which apparently you watched at one time and you lost your faith. Watch it one more time. We'll get you back, Jordan. Okay, thank you. Go ahead. Was my time up?
All right, thank you. Yes, just on time, actually. Perfect timing from the both of you.
First time I've been on time.
I appreciate it. Let me exit the full screen here. And now we're moving into uninterrupted rebuttal. Rebuttals from the both of you. We got 5 minutes on the clock. So for this one, I'll give you a 1 minute warning unless you guys are right on time like you were for the opening statement. So Jordan, you are on mute. When you're good to go, the floor is yours.
All right. So to start with, I said that nearly every expert agrees with me. I'm not making an argument from quantity of experts. It was just a statement. But I'm really glad that you focus so much on thermodynamics. I'm a mechanical engineer, so that's like my thing. The first law of thermodynamics states that the amount of energy in a total system in a closed system can't change. It can't go up or down. The sum total, if you add it all together. So what that means is that either the energy balance of the universe has to be 0 or the energy is eternal. Neither one of those require a god. So there are some cosmologists who have come up with models where, including some Christian cosmologists like Aaron Wall, who have models where if you sum all of the energy of the universe up, the gravitational energy being negative and the stars and us and everything else being positive, it actually could equal to 0. There's reasons to think it would, in which case, no violation of the first law. Or if the energy simply predates the universe or whatever, also no violation of the first law. At the end of the day, until we have a good theory of quantum gravity, we're not going to really understand what happened before the Big Bang. So it is a singularity. It's a gap in our knowledge, and I'm perfectly comfortable admitting that. That doesn't mean the universe is 6,000 years old. Matter didn't go faster than the speed of light. So the reason that you're saying matter can't go faster than the speed of light is special relativity. That's a limitation by that theory. However, that's a theory that is a limit on matter moving through space. It is not a limit on space itself. Space itself can do whatever it wants, including expanding faster than the speed of light. That's no problem. It's a prediction of general relativity. Look at Alan Guth's work for that. So we weren't the center of the universe. I know it seems like we would be if everything's moving away from us, but if you draw dots on a balloon and look at the perspective of any dot as it's inflating, it would look like all the other dots are moving away from it, but none of them are the center. So we're not saying that we're the center of the universe. So where does this heat come from in radioactive decay, you asked? Well, the technical answer is it comes from mass defect. When you when a decay happens, you have a difference in the mass before and after, because there's some mass or energy that's eaten up in holding the atom together. You don't need that energy anymore, so it's released. That's where it comes from, if you want the technical answer. But I think really what you're getting at is, where do these radioactive elements come from? And I'm sure you're aware, they come from nucleosynthesis in stars. So either in the hearts of supernovae, or more commonly in neutron stars where the gravity is extremely dense. You don't gain energy from fusing past iron because of the binding energy per nucleon. So you couldn't make a fusion reactor that burned up to uranium, but that doesn't mean you can't get to uranium through fusion. You definitely can. So yeah, that's where that radioactive materials came from. So the second law you spent on the second half talking about. The second law of thermodynamics, contrary to what many people think and what they might have told you in high school, does not mean that everything is tending towards decay, or it doesn't mean that things are becoming less complex over time. It doesn't mean any of that. What it means is simply that entropy increases, full stop. Now, what's entropy? Entropy is not disorder. Entropy is not complexity. Those are sometimes useful concepts to kind of get a general idea of what it means when you're communicating to a high schooler. But the precise definition is something more akin to how many ways you can arrange the atoms or the constituents of a system without making a macroscopic difference is one way of describing what entropy is. So the sum total of entropy in the universe has to increase over time. All that means is that the entropy at the very early universe was low. Why was it low? Don't know, but it was. So we've had plenty of room to increase in entropy since then. Actually, gravity, the clumping together of matter, increases entropy. Black holes have an extraordinary amount of entropy. So there's no problem with the second law with complex structures forming. When it comes to life, this debate is not on evolution, but since you touched on the second law, life would only be a problem for the second law of thermodynamics if there weren't enough entropy around for us to get started. And that's not the case. In fact, we're entropy-making machines. We take highly ordered light from the sun, use it up, and then emit light into the universe. We emit about 20 photons for every photon we receive. That means we increase the entropy about 20 times. So we're entropy-making machines. Without the second law, we couldn't have life. We couldn't have the universe we have. So, I mean, I guess it's a good thing we have.
30 seconds, Joe. 30 seconds.
You said everything is improving, or it would need to improve to get to radioactive decay or whatever. That's not... improving implies a goal. There's no goal here. It's just physics. Physics doesn't have a goal. So... yeah, I think this is mainly predicated on a misunderstanding of what thermodynamics really states. And that's my time.
All righty, with 5 seconds to spare. So thank you for that rebuttal, Jordan. We are now moving on to Dr. Hovind. You've got 5 minutes of uninterrupted rebuttal time. The floor is yours whenever you're ready.
Well, thank you, sir. I'm surprised he said gravity is negative, and gravity is a force. Anyway, we can go off all the details if you'd like, but there are two ways to look at this argument about the age of the earth, the biblical answer and the scientific answer. I think they're both going to come up with the same thing. The Bible says clearly God created the heaven and the earth, and in John it says Jesus was God in the flesh. In the beginning was the Word, and the Word was God. All things were made by him. The Word was made flesh. So Jesus is God in the flesh, and Jesus said, it's by him were all things created. So I think the Bible, whether you believe it or not, obviously you don't, but the Bible clearly teaches that Jesus is God Almighty in the flesh. Jesus said in Matthew 19:4, have you not read that he which made them at the beginning made them male and female? Here's Jesus claiming the creation of Adam and Eve was the beginning. So obviously, well, and again, I'm sure you don't care, but you are calling Jesus a liar, or calling the Bible a liar. Mark 10:6, from the beginning of the creation, God made them male and female. But Jesus did it, he ought to know. The Bible says man brought death into the world. God made a perfect world, man wrecked it, and because of man's sin, there is now death and suffering. It says that in 1 Corinthians 15 and Romans chapter 5. Man brought death. Jesus said the creation was the beginning, and the Bible says nothing died till Adam sinned. And God wrote on a rock with his finger, according to Exodus 20, that in 6 days the Lord made heaven and earth, the sea, and all that in them is. So that's what it says. God said it's a sign about him making everything in 6 days and resting one. There's lots of references to the 6 days of creation throughout the Bible. And the Bible says clearly that Adam was the first man and Eve's the mother of all living. So Jesus said the creation of Adam was the beginning. The Bible says nothing died till man sinned. And the Bible says we all came from Adam and Eve. So you add up the dates in the Bible. Adam was 130 and he had a son, and that boy was 105 when his son was born, and 90. You go through Genesis 5, it's easy to add them up, make a chart. You're going to come to the same conclusion. Everybody's come through all through history that's done this. The Bible teaches about 4,000 years before Christ was the creation. That's what it says. Now, you don't have to believe that, and I know you don't, but that is what the book teaches. So the Bible says nothing died. In your theory, Jordan, you believe death brought man into the world. Billions of years of malformed, suffering, struggling, half-formed misfits died in order for the improvement to take place. So if one animal evolves a little better than the rest, all the rest have to die for this new improved species to pass on its genes and take over the world. And this has to happen trillions of times to go from an amoeba to a human. So in your religion, death brought man into the world. In my religion, man brought death into the world. These are polar opposites. And you guys have to have billions of years for your theory to make sense. Certainly the textbooks do teach billions of years. The fact that a lot of people believe that doesn't make it true. In many Hindu countries, they teach you have to drink cow pee to be healthy. They'll drink the urine from a cow. A lot of people believe that. Okay, that doesn't make it true. Just because a majority believes something has never made it true. The majority has often been wrong. Whole bunch of people, 55 million of them, followed Adolf Hitler. So let me get to where I want to go here. Beginning right there. So how old is the Earth? Could it be demonstrated that the Earth is not billions of years old? Let me go up to slide 465. There are numerous scientific ways to show the universe cannot be billions of years old. This one topic of time completely crushes the evolution theory, and you know it. If they take away time, now the only option is there had to be a God, and that's going to bring some accountability. Jordan, I predict if we got to know each other pretty well, I could find out that you really abandoned Christianity because of a lifestyle problem, not because of a scientific problem. You take away time, it's the pacifier for the evolutionist. They will scream like a baby. You have to have time. We look at all kinds of things. The galaxies are spinning. I don't think anybody argues about that. But the galaxies are going faster in the middle than they are at the outside. All the spiral arms should have disappeared by now. Why do the galaxies have spiral arms? And you know, I go through my seminar many different scientific evidences. Jupiter is cooling off. I just want to show one of them here. Right here. Ganymede is cooling off. There are all kinds of things that are cooling off, like you mentioned. Well, then that means they used to be hotter, and that puts a time limit, how far back you can go. Saturn's rings are expanding. There we go. The moon is going around the Earth, but the moon's getting further away. It's leaving us. I feel like we're drifting apart. Spaceplace.nasa.gov. Yes, right now the moon is moving away from the Earth, from Forbes, about 2 years ago, at the rate of 4 centimeters a year. The moon is leaving us. Astronomy books are fond of quoting the fact the moon is gradually spiraling away. Why is the moon leaving us? Right now, the moon is moving away. The moon is leaving us. There's all kinds of stuff on the internet. The moon's distance is increasing. Well, now hold it. If you run the math on this, you'll find out that the moon can only be 1.4 billion years old. 1.4 billion years ago, the moon was touching the Earth. And you want to have 4.6 billion years for the Earth. I'm sorry, you can't. Can't have it. Just that one, the moon, destroys your billions of years. So go ahead.
Okay, awesome. Thank you so much. Gentlemen, great opening statements, great rebuttals. So we're now moving into the open discussion. Okay, the goal of this organic dialogue is to keep it free-flowing, equally timed, with as little interruptions as possible. And, of course, an attempt to keep it on one topic at a time. Why don't we allow Jordan to kick off the discussion, since Kent just ended his rebuttal. Therefore, Jordan, the floor is yours. If you wanted to start with a question or a couple points regarding Dr. Hovind's rebuttal or opening statement, go ahead, gentlemen.
Yeah, so I actually did the math on that moon thing, and the math is wrong, but I don't want to get hung up on that right now. I'd rather talk about radioactivity, so let's talk about that. So do you think that radioactive decay happened faster in the past? I think I've heard you say that before. Is that something you still believe, that radioactivity, the half-life hasn't been constant through time?
I have not said that. I have said you cannot prove it was always constant. I don't know if it happened faster or slower, and neither do you. I've never said that I know radioactive decay happened faster. I said that is one of the assumptions you have to go on. It's your problem. You're the one wanting to say the Bible's wrong and we should teach your religion in schools. The burden of proof's on you.
I apologize. I didn't mean to put words in your mouth. I must have been mistaken.
Okay, yeah. Prove the rate did not change. Go ahead.
So first of all, there's no mechanism for the rate to change. That's first of all. But secondly, I think I showed the rather catastrophic effects that a changing radioactive decay rate would have. So if you want to posit that the decay rate has changed, that has implications. You can't just say it. It means things get more radioactive. And if they're more radioactive, there's more heat. So if the radioactive decay rate has in fact changed, then the Earth would have been melted. Noah would have been blasted with, like Hiroshima would have been nothing compared to what Noah would have been taking. How do you get past those kind of problems?
Well, you're talking about radioactive decay. What process do you have to get up to the higher elements so that they can decay? What we see is the elements decaying down the chart. How do you get up the chart? What's your mechanism to do that?
Nuclear fusion.
What's nuclear fusion? You have to have a lot of energy to do that. Where's this energy coming from? You're back to the first law of thermodynamics.
Hearts of stars.
Energy can't be created or destroyed.
It doesn't need to be. So stars have a lot of energy, as you may be aware.
Where did they come from?
So the original matter was there at the beginning, and from there, the universe expanded.
Okay, Jordan, now would you admit that you have to take that on faith? You have a religion. This is not science. You cannot say, well, it was just there. That's not science. That's a religious statement.
There is a difference between saying, I don't know, and saying it must be. So I don't know. Perhaps the matter simply existed forever. The energy simply existed forever. That is perfectly consistent with the laws of thermodynamics. I don't know if that's the case, but it is consistent.
Right. I understand. You want matter to be eternal.
It could be.
Would you agree? Would you agree, for the audience here, for the record, Your Honor, this is a religious statement. You cannot know that scientifically. We know matter decays. We know we lose energy, it dissipates. It'll finally go to zero someplace. So you have to take by faith that you have an original starting point of a bunch of matter and energy.
You're using the word decay imprecisely. So, and this is what's going to cause confusion with some people in the audience who may not be as familiar in nuclear physics.
I think they see it clearly.
So the decay I'm talking about is a very specific function of elements when their balance of neutrons and protons is out of whack. That's what decay means. It doesn't have anything to do with thermodynamics in that. Well, obviously you can't violate the second law, but that's not what I mean there. The elemental composition of the early universe has nothing to do with whether or not we can get uranium today. All you need is enough energy to overcome the barrier, the resistance of protons to meld together. That's all you need. There's no magic here. It's simple general relativity, and so that's where the energy came from. So
wait. Stop. Don't go so fast. You're saying all you need is enough energy to make this happen. Well, who made this energy? You're bypassing this. This is a religious statement.
Once again,
you give me enough energy and I can stop. Where'd the energy come from? And where did the space come from for all this to happen in? And where did time come from?
It is an open question as to the mechanisms that happened prior to the Big Bang. But that has nothing to do with what happened after.
Okay, would you grant me the courtesy of then saying, because it's an open question, we don't know where the matter, time, space, where the Big Bang, that this should not be taught in schools as science, because it's a religious belief. No, we're all paying for your religion to be taught. I resent that. Go start a Reasons to Doubt school and pay for your own stupid religion to be taught. I don't want to pay for that to be taught to the kids. You don't have a science to back you up, Jordan. You start with a religious belief. That's like me saying, if I had $1 trillion, I could stop. I don't have $1 trillion.
So here's what you're doing. You are looking at this problem. You've got radioactive decay produces a ton of heat. Radioactive decay would kill everyone involved in the Bible. Radioactive decay would do all these things. It's a mechanism we know. And you don't want to answer that question. You don't like it because it's a problem. So instead, you keep harping. Well, if it's not a problem, then answer it. If you keep harping on this energy thing, which I've already said is an open question, we don't know. But that doesn't mean we don't know what happened afterwards. Just because we don't know what happened here doesn't mean we don't know what happened from here to here. So I will happily admit that nobody knows the exact mechanisms that happened prior to the Big Bang. Okay, we can give you that point. Now, from there, how do you address the heat problem that is accepted by creationists like Snelling? Like, how do you address this problem? You can't just say, well, I don't know. You can't just say, I don't know, therefore God, you know. It is a physical problem based on physical laws, such as the strong nuclear force. How do you address it? Okay.
Would you start with the assumption? Let's take carbon-14. Is that the one you wanted to talk about, or which one? Uranium.
Well, if we're talking age of the Earth, then uranium-lead would probably be the more useful.
So uranium decays to lead. You agree lead is a lower number on the periodic table than uranium, I would assume, right?
Sure. Has a lower number.
So again, you don't have a mechanism to go up to uranium. You got a mechanism to go downhill, which everything goes downhill, not uphill. So your assumption that this was going to cause a problem for the people on Noah's Ark and burn their skin and all that stuff, like you talked about, or whatever the illustration was, you have so many assumptions built into this. Where did the uranium come from? Was this a problem before? The Bible, I teach and believe very strongly that there was a crystalline canopy above the atmosphere. The Bible says there was water above the firmament in the first chapter in the book, Genesis chapter 1. And the Jews have always taught there was a crystalline canopy 2 or 3 fingers thick above the air. So if you took the current air, which just stretches out who knows how far, 100 miles maybe, squeeze it down into 10 miles, put a crystalline canopy over the top to contain it, you increase air pressure, you block out the radiation from the sun, you don't have the formation of carbon-14. Doesn't even start beginning until after the flood. So it's not a problem.
We're not talking about carbon-14. We're talking about uranium and lead.
Okay. Well, you're saying uranium decays to lead and produces so much heat. Is there uranium decaying to lead today?
Yes.
Is it producing enough heat to kill everybody on the Earth? I feel fine.
No, because of the speed. So, like I said, the current heat produced by uranium and thorium today is about 20 terawatts. That's a completely manageable number because of the speed at which it's decaying. In order to fit your model, we have to speed up that decay, which means.
Why do you say that? Why would you say it has to fit? Why speed up the decay? What if it's always been the same from the creation?
Because of certain observations, such as the Oklo phenomena. So, if you don't think that you need to speed up the decay, how would you explain something like the Oklo phenomena?
Explain the what? The opal phenomenon?
Okay, so I said it in my presentation, but basically there was a naturally occurring nuclear reactor at the Oklo mine in Africa. So in order to have a nuclear reactor of that type, you have to have uranium that's enriched to 3%, and you have to have water. So natural uranium right now is enriched to 0.7%. You need, at the current decay rates, it would take 2 billion years to get it enriched to 3% over time. And so if you don't have...
Is this a process that some people are doing in a laboratory trying to enrich the uranium, or does this happen in nature?
So it happens
just enrich itself?
So what I'm saying is right now it's 0.7% enriched, and uranium is decaying away, right? U-235 decays faster than U-238, so over time, uranium is becoming less enriched, which means if you go back in time, it becomes more enriched. You know, the uranium from 1,000 years ago is more enriched than uranium today, because that's how lines work. So if you do the math, and I showed a graph, I'd be happy to pull it up again if it's more illustrative. But if you trace that line back, you can simply do the math based on half-lives. It takes 2 billion years to arrive at the enrichment required for the phenomena we see.
So 2 billion years ago, the uranium was 3% enriched. Is that what you're saying?
Yes.
How did it get that enriched? Where did that come from?
So U-238, so natural uranium consists of 2 isotopes primarily, U-238 and U-235.
Right.
U-238 decays slower than 235, right? So the amount of 235 in uranium is decreasing over time because it's decaying way faster than the rest of it.
The amount in both of them is decreasing over time.
Yes, but one is decreasing faster.
Right, so, I understand. At least it is now.
Sure.
What we observe today, we've only observed this for the last 100 years, right?
Well, see, but that's what I'm saying. If you want to tinker with the decay rates in order to make this process happen faster. That has implications. That implication being the Earth would melt. So do you think that God simply created Oklo exactly as we see it today? Is that the solution?
I'd have to do some study on that. I'm interested in that, and I will. I'll research that. I don't know. I don't have a quick answer for that. But I'm still curious of how you're getting from uranium-235 decaying or uranium-238 decaying and calling that that's another example of the violation of the thermodynamic laws that you guys want to start with a dot making all this uranium. How much uranium is there in the universe? And that was all in that dot?
So first of all, I want to compliment you on being willing to say you need to look at something. It's a great model for everybody here. There's no.
Yeah, if I don't know, I'd look it up, and I'd like you to do the same. Okay.
Yeah, sure, definitely. So I don't know how much uranium is in the universe. So I don't have that number at my fingertips. It's a lot, I'm sure. So the way we get that uranium is through fusion. Fission decreases. Fusion, right. Mashing protons together would increase it. So that's how you do it.
What's fusing? Where did that come from?
Protons and or neutrons would be fusing.
Okay, so where did these protons come from in order to fuse to make this?
So they're in the center of these neutron stars or in dying stars.
So where did the star come from? I'm going to go to the same thing every time because you don't have an answer, which is why you have a religion, but you guys can never admit it's a religion. It's not science. It's a religion.
So it sounds like you're making a God of the gaps argument. It sounds like you're saying because the cutting edge of physics hasn't pushed us back before the Big Bang, that therefore God fits there, I guess.
Oh, no. But see, I'm not asking for my God to be taught in the school system. You are demanding that we all pay for your God to be taught in the school system. I think we should avoid the subject altogether. You can learn all about biology, anatomy, nuclear fusion without getting into the age of the universe and without getting into origins. But no, they don't do that. I've got the books right here beside me. They take what we observe of radioactive decays, and they take what we observed about stars exerting a red shift, etc., and then they insert their religion in with it. See, boys and girls, this proves it began as a Big Bang, and it doesn't prove any such thing. We see the stars moving away. I agree. That does not prove they all started in a dot smaller than a period on a page. And it does not prove it was 13 billion years ago. We've only watched them for a couple hundred years get the red shift. I don't know when Hubble did that in the last 100 years. Yeah. So it's true. We see a red shift. The creationists have a quick answer for that. 17 times in the Bible, God said he stretched out the heavens. But I'm not asking for that to be taught in the schools. You guys are demanding that your interpretation of this data, i.e., look at this, boys and girls, red shift. That proves Big Bang. No, it doesn't. But you're demanding that I pay for that to be taught. Why don't you go start a private school and teach Big Bang to those who want to pay for it? The majority of Americans in surveys have said they resent all this stuff being in the textbooks. It's not part of science.
So
teach real science.
If you waited until you understood every single facet of every field to teach anything, no one would ever become a scientist because that's not going to happen. We can only teach. True. We can. Science, we don't understand fluid dynamics. I learned fluid dynamics and we don't understand that. All our equations are empirical. So by your standard, we shouldn't teach fluid dynamics because we don't know.
Gravity is. Nobody knows what light is. Nobody knows what gravity is. Nobody knows what a thought is. What does a thought weigh? We don't know.
So we can only teach what our present understanding is, always with the understanding.
And that's where they should stop, but they don't. They say, we see a red shift. We think it's caused by the Doppler effect, and I would agree. And then they go on and insert their religious belief. This proves the Big Bang, and it doesn't. It's a religious belief. You may believe it very strongly, but it's not part of science. Science means knowledge. We should teach what we know. And when we reach the gap where we don't know, we say, I don't know. Where did God come from? I don't know. He claims he's just always been. I don't understand that. But the infinite God won't fit in my 3-pound brain. So I don't have a problem with that. I've chosen by faith to believe that. You've chosen by faith to believe energy is eternal. You said so earlier. Maybe energy is eternal. Jordan, don't you see?
What I said was I don't know. I didn't say I believe. I don't know.
No, I think I wrote it down exactly.
I said it is a possibility that energy is eternal. It could be. I don't know. It wouldn't violate any laws of physics that I'm aware of, but I don't know.
So you said that space can expand faster than light, like the dots on a balloon?
Yes.
Isn't that still moving the dot faster than the speed of light if it's stuck on a balloon?
If you compare the distance between two pieces of matter, they would be increasing faster than the speed of light. However, the limitation you're talking about is from special relativity, right? Right. So the limitation you're appealing to is from special relativity. General relativity, which is the theory that supersedes special relativity, is which treats space-time as curved, says that space can expand, and it doesn't. There's no speed limit there. The only speed limit from special relativity is from objects moving through space. See, special relativity doesn't include gravity. That's by definition, that model doesn't. So when you include gravity, you can't use special relativity anymore.
Okay, let's get back to the fundamental. Where did time start? If it started 13.772 billion years ago with time, space, and matter, and a dot of near nothing exploding and expanding like your balloon, what was 14 billion years ago, and 15 and 22 and 300 billion years ago? And if time is eternal, going back in time, how could we ever get to today? You could never get to today.
So that's a really interesting question. It depends on which cosmologist you ask, because again, it's an open question. There are some cosmologists like the Carroll Chen model has an eternal universe in both directions. So the Big Bang would be a unique moment of low entropy in the middle. There are some people like Stephen Hawking who propose that there was a smooth surface at the beginning, and basically the question of before the Big Bang just doesn't make any sense because there was no before the Big Bang. Before is a meaningless concept before when time comes into existence. Which one it is, I don't know.
I can say the same thing. God created it. What was before that? He made time. He says he made time, space, and matter. He's outside of those.
Well, you'll notice I didn't ask you where God comes from because, you know.
Sure. Okay.
Yeah.
Well, the point is, I admit I believe God created the heaven and the earth. You guys should admit that you believe, i.e. religious belief by faith, that matter created itself, or energy created itself, or has always existed.
Okay, so I think I understand the confusion. So the Big Bang cosmology actually doesn't say anything about the moment of the Big Bang. That moment is unknown. It's a singularity. Our laws of physics break down. Nobody claims, if they understand what they're talking about, that we know what happened then. Big Bang cosmology picks up after that. We don't know what goes on here, but we do know from here forward. So if you ask a cosmologist, they'll tell you, we don't know the moment, but we know after that moment, this is what happened.
Okay, I don't think you know after that moment either. You have, all we see is there's a red shift. Everything else is interpolation from that. I can take the same fact, there's a red shift. I agree with that. And come to a different conclusion of why. My Bible says 17 times God stretched out the heavens. That would cause a red shift. The star is receding from us. And it could only be 6,000 years old and still be 14 billion light years away. So I don't have a problem with that.
The cosmic microwave background would be what?
I don't know about the cosmic background radiation. But as far as where did the time, energy, and matter come from, we know energy is decaying. We know every thermodynamics, everything's falling apart.
Well,
but you want to start with a dot of nothing.
It's increasing in entropy, falling apart.
Okay. That's the same thing. I try to keep things simple. It's increasing in entropy. It means everything's going downhill. It's falling apart. Your bedroom falls apart. Your house is going to increase in entropy, going to gradually decay. Everything gradually decays. So how do you get from a dot of near nothing into complex galaxies, a planet? Do you believe the whole Pacific Ocean was in that dot?
So the smooth, hot, dense universe of just after the Big Bang is low entropy. The universe of today is higher entropy. Galaxies and planets and all of that are higher entropy than the smooth surface of the Big Bang. The reason for that is gravity. When you have gravitational attraction, it causes things to move around, to bump around. There are more configurations that it can be in. That's what entropy means. There are more configurations it can be in as a star than it can in that hot, dense state. So there's no problem with entropy. Entropy has, in fact, increased. That's why it's not helpful to treat entropy as if it were complexity, because entropy and complexity are not the same thing. You can have an increase in entropy with a decrease of complexity. There's nothing violation there.
Okay. Yeah. Would you agree that there are certain particles that repel each other, like protons and like charges repel, right?
Until they overcome the Coulomb barrier, yes.
Right. Okay. Other charges, other particles attract each other. Electron and proton will attract each other.
Mhm.
Gravity is an attraction of masses. Where did this law of gravity come from? Who made gravity? And exactly what is that? You're relying on gravity holding all the matter in the universe. The whole Pacific Ocean was in that dot, smaller than a proton.
So,
can you explain that?
A physicist could explain it. That's what general relativity is. General relativity is a model of gravity. And it is complicated. It is difficult to understand, but the universe is complicated. Like just because a model is complicated doesn't mean it's wrong. Just because it's difficult for any...
I understand.
Yeah, right. So just
but
because it's...
Understand, I would use a different adjective. No, it's not difficult to understand. I think it's stupid. All the matter... You cannot squeeze all these protons and electrons into a dot that small. There's a lot of material in the universe. I would give you $1,000 if you could squeeze a bowling ball into a dot the size of a proton.
I can't, because I'm not existing at the conditions of the very early universe. What you're saying is, right now, with the physics you have available and the environment you have available, do something that occurred in a completely different scenario. That's not a reasonable objection.
Well, that's not science either. You're assuming, you're believing that it was a set of assumptions back then, different universe back then. We don't know that.
That's a prediction. It's a prediction of general relativity. Do you accept that general relativity is an established theory? Is that science?
I'd like to see more about that. But the fact is, you're not answering these laws, the law of gravity, the law of attraction of opposites. Who made the laws? Who made the matter? Who made the space for all this to happen in? And who made the energy for all this to happen? You want to just start and bypass that. We don't know what happened, but we know what happened after that. Well, I don't think you know what happened after that either, but I think that's important. You give us a starting point. My Bible does that in 10 words in the very first verse. In the beginning, God created the heaven and the earth.
So
you take yours on faith, and for you, on faith, there was time and matter and energy and lots of energy. And from there, you can build your theory. But your first step is on faith. It's a religion. So
if it weren't taken on faith, then it would be an affirmative fact, right? I'm not saying I know where these things came from. Now, in terms of the laws, laws are descriptive, so they are a description of the way the universe works. Why it works that way is, again, unknown. It could be because of string theory, and there could be different configurations. You've got multiversal models, but none of that has anything to do with what happened after that point. That's like saying, if you don't know, if you've never been on the other side of the mountain, so you don't know what's over there, you can't teach about what's over here. Well, I know what's over here. Like I don't have any clue what's over there, but I can still teach my kids about today, about what's here, about what I can observe.
You got it. I agree.
Yeah,
we observe.
That's all we're doing.
We observe man has 2 bones in his wrist, and they work really good, the radius and the ulna. We observe a lot of things. We observe, hey, the whale has the same, similar structure, 2 bones. Wow. That's fine. That's observable. That's science. But then to add to that, see, boys and girls, that proves they're related. No, it doesn't. It could easily prove they have a common designer. But you guys want your religion taught at everybody's expense. So you said there may be a couple theories about the string theory, et cetera. What about the theory God did it? Is that even on your radar?
So that has a huge assumption involved, that there is, in fact, this
and Big Bang doesn't have a huge assumption involved?
All the Big Bang requires is general relativity, which we have established as it's a well-founded, good theory. And it requires that there is matter and energy, the matter and energy we currently observe. That's it. That's all the theory states.
That's your God. That's your God.
I mean, you can call it God if you want. That's a kind of misuse of terms. But
I'm sure you don't want to call it that, but that is what it is. That's your God, Jordan.
I'm not
the real God.
I mean, at least,
energy.
At least I can observe my God exists then. It seems like a big advantage. I don't know. That kind of does it for me.
Okay. That does it for you. That's okay. But I would like you to keep that to yourself and those who want to pay and come learn that. Okay. I don't want to pay for that to be taught.
I mean, so this distinction between science that you can observe today and the science of the past seems like a kind of an arbitrary distinction. Like we don't make that distinction with a detective, for example. If a detective goes into a room and has observations of this body and blood and whatever, and he's inferred, oh man, because of this DNA evidence and everything, I can infer that so-and-so did it or probably did it. What you're saying is, no, you weren't there. You didn't see that. You can't infer that. All you can say is that it's right like this right now. That's silly. Like, of course we can make inferences about the past.
True, and sometimes they can be seriously wrong. In the movie The Green Mile, it's a fact. 2 girls are missing. It's a fact they're found dead. It's a fact John Coffey standing there holding him, crying, saying, "I tried to take it back." It's a fact. It's a fact he was arrested for the crime, and it's a fact he was tried. It's a fact he was found guilty, and it's a fact he did not do it. So it's possible to look at all the evidence and come to the wrong conclusion. The Green Mile is a simple example of that. I think you guys have looked at the evidence and come to the wrong conclusion. You've already decided, we know God didn't do it. Now, let's find another way. I think, like the Bible says, they scoff because of their lust. They don't want God to tell them what to do. And I said at the beginning, and I'll repeat it now, I think there's a moral reason. I don't know you at all, but I suspect if you really got to talking, you'd say, I really gave up on God because he didn't like ABC and I wanted to do ABC, whatever that was. Maybe not.
He didn't like my monogamous relationship with my wife or my loving 4 kids, I guess. I don't know.
Oh, I have no idea. Maybe it's a different area. I don't know.
So I will say for sure, if anyone thinks that we're absolutely certain about a conclusion like general relativity's efficacy or whatever, nobody is absolutely 100% beyond a doubt certain, because that's not the business of science. No conclusion in science is ever absolutely certain, as in could not possibly be wrong later. What we do is we progressively get closer and closer to the truth because we build better and better models, but we're always open to those models being shown to be wrong. But what we can do is eliminate more and more things and thus get closer to the truth. That's all it means. But you want to talk about the moon distance thing, because that calculation is definitely wrong.
This calculation is wrong. Let's see. Who said this? This is from Astronomical Journal 30 years ago, 25 years ago. They said the orbit collapses 1 billion years ago. This is from Astronomical Journal. Are you smarter than these guys?
That was in 1954. The better research would be
November 1994, 25 years ago. They said the lunar orbit collapsed a little over 1 billion years ago.
I'm talking specifically about the recessional thing. You said that if you go back using that rate, 3.8 centimeters per year.
Well, right? that rate would be logarithmic. You understand that. It would not be linear.
Okay. Well, if you're not going to use it as logarithmic, as linear, if you're going to allow it to change, it's not the fact that it would necessarily speed up over time, because it's more complicated than that. The inverse
is complicated, which is what I have here. Is the moon moving away? I just downloaded these today. Curious.astro.cornell from Cornell University. Yeah, the moon's moving away about 4 inches or 4 centimeters a year. I think it's obvious. You can observe this. The moon is moving away from the Earth. Would you agree that means the moon used to be closer?
Yes, but not as close as you've said.
Okay. Well, everybody is saying this creates a time problem. It moving away 3.8 centimeters a year, and it's inverse square law. If you bring the moon into 1/3 the distance, it's now 9 times the gravitational pull. So the problem becomes greater the closer you bring the moon. So that's why it does collapse. Certainly less than 4.6 billion years ago. So this still raises the very obvious question: where did the moon and Earth come from to begin with? It had to be spinning around. How did the orbit get started? We know it's moving away. This is an observed fact. We can see it moving away. So if this did take away your 4.5 billion years and reduce it to 1 billion years, like they say, let me see, I got it up here. If I could show that scientifically the Earth can only be 1 billion years old, would that harm your evolution belief?
I'm not an evolutionary biologist, so I actually have no idea how long it takes. If 1 billion years would be sufficient, I don't know. What I do know, that'd be a great question for Richard Dawkins. I don't know, but what I do know is
I'll debate him any day. Bring him on.
If I can get him on, I'll do it.
Sure, please do.
What I do know is that the latest research, at least the latest research that was done on this, which was done in the 80s, showed that it's not as simple as that. So the inverse square law, what that is if you half the distance, you'll double the strength. That's how the inverse square law works.
If you half the distance, you quadruple it.
Yeah, you're right. Half the distance, you quadruple it. Right?
Of course, I'm right. I'm going to win this debate. Go ahead.
So, but that's what you're saying is that because of the inverse square law, the attraction would increase and therefore would come in faster. Am I understanding what you're saying? The rate of approaching it faster.
That's observational. If you take two magnets that attract each other, As you get them closer, the pull is stronger, and pretty soon they snap together. You can't separate them. And that's what they've been saying in all these arguments. Look, it's a 1.2 billion max. Some people say 1.4 billion. Either way, it's less than 4.6. And you guys all your books are saying you got to have 4.6 billion years for evolution to happen. It doesn't even happen then. We've never seen a cow produce a non-cow ever. But they believe that an amoeba could turn to a cow over 4.6 billion years. I think just the moon is going to reduce it to 1.2 or 1.4 billion years ago. That's what they're saying.
So citing peer-reviewed research, Bills et al. In 1999 stated that to our mind, the dynamical solution of the timescale problem for lunar orbit evolution has been solved by the oceans model presented by Hansen 1982, Webb 1982, and he goes on to cite more sources, and that even if you go back 4 billion years, that you wouldn't have a problem with the moon hitting. So if you cite the most recent research,
I will read that. I promise you. Okay.
Okay. Cool.
Okay. But would you agree it puts a time limit of any number? Maybe it is 4.6 billion. That would put the moon pretty close to the Earth, and the moon is receding. So that's going to make the tides much higher. With a closer moon, you got a real tidal problem now. Not only a water tide, but you have an Earth tide. The Earth's crust is going to flex in and out as the moon goes around or as we spin under this close moon. And so that's going to create constant earthquakes. I think you have a lot of problems going to be created just by bringing the moon closer. So a lot of physical science problems.
Again, it's more complicated than just it's closer, therefore it's stronger. When you do bring it closer, you would have the object's stronger, so its gravitational pull would be stronger. But what actually causes the tide is the tidal torque, and that is actually very dependent on the configuration of continents and oceans, according to the papers that I cited.
Well, that causes the height of the tide, but the effect of gravity, the pull, how much it pulls is only dependent on the distance. How it affects the Earth, the water, is dependent on continental shelves and depths of water and all that kind of stuff. Tide in the middle of the ocean probably only goes up and down 2 or 3 feet, but at the beach it'll go up 5 or 6 feet or 60 feet at the Bay of Fundy in Canada. Alaska, the Bay of Fundy, about 100 feet, I think, is the world record tide. So this is dependent on the topographical surface. I understand all that. But still, it increases as you go back in time, the tide washing away the beaches and eroding the continents, being just by the closer moon. It's going to make not only just a gravitational problem of it collapsing, where you have to explain the origin of the moon and the Earth and this problem. Somebody may think they have done some math, and you said the math is wrong. I believe me, I'll study up on that. But you got just bringing the moon closer makes a lot more beach erosion and the tidal problems. I don't have a problem with that. It's not billions of years old, so my problem's solved.
So I would agree that the lunar recession, when taken in totality with the most recent research, would put a limit on the age of the moon, and it's possible that could then lead to a limit on the age of the Earth. But if that limit is 4.5 billion years, then it completely fits with the current model of Earth's age, so it's no problem. Just because there is a limit doesn't mean there's a problem.
Okay. All right, we've gone a long time.
Jump in here real quick.
You got questions?
Yeah, I was going to point out that was, yes, that was 30 minutes for the discussion about a couple minutes ago, but you guys were going at it and having fun. I didn't know when to jump in. So that's a good place to end it. We've got a probably 10 years worth of questions. What I'm going to do is I'm going to put 15 minutes on the timer. We'll do 15 minutes worth of questions. Make sure we get to the super chats. Did you gentlemen want to take a minute to wrap up your points in the form of like a concluding statement, concluding thoughts before we go into the Q&A? It's totally up to you, gentlemen.
Go ahead.
Yeah. So usually in a closing, you relitigate the points you made in the debate. And I could talk a lot about the radioactive decay and all that, but you can this is YouTube. Just go back and listen to my points if you want to hear the argument litigated again. What instead I'll say is I'm an engineer. I am not a physicist. I'm not a geologist. I'm not a cosmologist or any other kind of ist. So I'm not an expert in any of these fields. There's too much human knowledge for everyone to possess it all. So if you want to get your physics, you should go to a physicist. If you want to get your biology, you should go to a biologist. So you shouldn't take my word for it when I say these things. You shouldn't take Dr. Hovind's word for it when he says these things. You should go read the peer-reviewed literature, talk to the experts, see what the experts see what a variety of experts say, see what the Christian experts say, the Jewish experts, the Muslim experts, the atheist. See them all. But what you shouldn't do is say, well, this seems complicated. I don't understand it. Therefore, it's wrong. Sometimes life is complicated. Instead, rather than saying, these scientists believe this thing that seems stupid, so therefore they're stupid, say, hey, this seems stupid. What do the scientists know that I don't? And then go answer that question. So do that, and I think you'll come to a conclusion closer to me than Kent. But either way, you'll be better off. So,
thank you. I agree. We should be looking. Well, I'll share with you very quickly what most people call Pascal's wager. You really understand, Jordan, if you are right, and I am wrong, I've lost nothing. Absolutely nothing. I have had a wonderful life. I enjoy my life. I enjoy my dinosaur adventureland. I laugh till my sides hurt. I enjoy life. And if I die and I turn back to dust and there's nothing after that, I had a good life. So we both are the same. If you're right, I don't lose anything. Now you understand fully, I think, that if I'm right and you're wrong, you've lost a lot. You have stand a lot to lose here. So Pascal's wager, I think, certainly would be on my side. You said you're an engineer. My dad was an engineer. My brother was an engineer. My mother was a teacher. My other brother was a teacher, and I was a teacher. And I love engineering. I love mathematics, and I will study some of this stuff. But you said you should read what the experts say. I did. I know the author of the book personally. I read what he said. He said he did it all in 6 days. He wrote it on a rock with his finger and handed the rock to Moses. I know him personally. He's my friend. He'd like to be your friend again. So I talked to the experts. He's the one who did it. I mean, there's nobody more expert than God. He's the one who made it. And he said he made it in 6 days. And he said he made everything to bring forth after its kind. He said that 20 times in the first 7 chapters. They're going to bring forth after their kind. What exceptions has anybody ever observed? Dogs produce dogs, cows produce cows. There are 60 varieties of, no, there are 8 varieties of bears. They might have had a common ancestor. Probably 1,100 varieties of bats. I go through this in my seminar. Sure, a lot of variation happens, but they're always the same kind. There are thousands of varieties of roses, and I guarantee, I'd bet you $500 if you crossbreed them, you're going to get a rose, not a banana, or a tomato, or a cow. Nobody has ever seen a single exception to the simple fact they bring forth after their kind. Now, exactly what is a kind? I don't know, but I think a 5-year-old will tell you generally, dog and a wolf are the same kind. Dog and a banana are not the same kind. I bet a 3-year-old would know that one. So the atheists hide behind that argument exactly what's the definition of a kind. And I don't think anybody's got one. They don't have a good definition of species either. Nor do they have a good definition of exactly what gravity is or light is. I can tell you what it does. I can tell you how fast it goes, but I don't know what it is. So I think that I'm going to stick with a simple belief that God said they would bring forth after their kind, and that's all we've ever seen. God said he made it all in 6 days. Well, that explains all the trillions of symbiotic relationships. Certain animals require certain plants. Certain plants require other plants. I mean, there's trillions of symbiotic relationships in nature. Did those all evolve by chance over billions of years? I mean, why did we get both arms up here? Why not an arm here and a leg here and another arm down there? I mean, why is there so much symmetry in nature? Why is there so much functionality? I look at nature. I love biology. I love earth science. I love physics. And I see God everywhere I look. I don't have a problem with that. Anyway, questions. 10 years worth of questions? I don't have 10 years tonight, brother, but I'll give you what I got. Go ahead.
No problem. I'm going to put a timer here, 15 minutes. We'll get through as many questions as we can. Gentlemen, you kept it cordial, equally timed. It was a very easy debate to moderate. And during the discussion, we had over 170 people in the chat. So very lively, very good debate. Definitely one to remember. So let me put the timer here for the questions. I'm going to get to the super chats first. And let's see. First one is for Jordan. So $10 super chat from Noble Eagle 100. Thank you so much. I appreciate it. Question for Jordan. Doesn't the law of cause and effect, the expansion of the universe, and the second law of thermodynamics prove the universe is not eternal?
No. So the second law of thermodynamics states that entropy increases. So if we had a low entropy beginning, we get to a high entropy state now, and there's no violation of the second law. The law of cause and effect, I think he's going into the first cause argument, the infinite regression. That's the Kalam cosmological argument. I've done debates on that before. So all that would tell you is that the universe has a cause. It doesn't tell you what the cause is. If you accept the argument as is, depending on your interpretation of quantum mechanics, there may or may not be a naive understanding of cause and effect, but it's not as simple as that. So If you want to see me answer it fully, go look at my debate on the Kalam.
I appreciate the response, Jordan. Dr. Hovind, did you want a quick response as well?
Well, yeah, I think the question was, does this demonstrate that the universe is not eternal? And that is, I think, quite obvious. If everything is winding down, burning down, losing heat, moon is receding, planets are cooling off, of course it can't be eternal. Now, the only question now is, what is the time limit? I don't see a problem with 6,000 years fitting everything in, if you include one giant flood to make Grand Canyon, and probably in a couple of days. So I think all the strata of the earth can be explained with this giant flood. So the Bible says at the end of time, the scoffers will be willingly ignorant of the creation and the flood, 1 Peter chapter 3. So, or 2 Peter chapter 3. That's, I don't have a problem. So the question was, does the laws of cause and effect prove the universe is not eternal? Absolutely. The only question now is, how long? He wants 13.77 billion years to turn his frog to a prince. I think God just made the frogs and he didn't make the princes. He made the people. Some of them made other princes out of them. Never mind. Go ahead.
And out of respect, of course, Jordan, since it was your question, you can have the last word on that one.
If I misheard the question, if it was eternal, look at cosmological models. There are some eternal cosmological models, so there's no problem there either.
All right. Okay. Thank you, gentlemen, for keeping that question lively. Next question, another super chat from Jungle Jargon. I appreciate, Jordan, you being a good sport. We've got a lot of questions for you. So they're coming at you. You know, we got a lot of creationists in the chat. So Jordan, simple.
Lion and a den of lambs.
Yeah, there you go. Okay. So question for Jordan. Energy. Energy cannot order itself. It can't happen through physics. So how did the energy get ordered?
Okay, so you can have spontaneous increases in order as long as there's a corresponding decrease somewhere else. Where order, I'm saying entropy. I'm using the term imprecisely. For instance, the formation of ice when it freezes outside. The ice itself, the water, has decreased in entropy. The total system has increase in entropy, but you had a local decrease in entropy. So according to the laws of physics, you can absolutely have things ordering themselves, so to speak, or coming to what we would perceive as better order just by following the laws of physics, as long as the overall entropy increases, which it always does.
Would you like a quick response, Kent?
Well, yeah, I think everything is falling apart. There might be a local order, like from water turning to ice as it loses energy, loses heat from 32 degrees down to 31 degrees. That's not an example that's going to help the evolutionist at all. And I think that's based on the assumption that the ice is more ordered. Water's molecules floating around freely. The molecule didn't change much. It just locked itself into a crystal. So I don't think that's an example at all that's going to help evolution.
And Jordan, it was your question. So go ahead, have the last word.
I don't need one.
Okay, no problem, guys. Okay, so here's a question for you, Kent. Question from David Neff. Question for Kent. What would prove evolution?
Well, you'd have to define the word first. I do that in my seminar. There are 6 different meanings or levels or stages to that word. We see what we call microevolution, variations within the same kind. That we can see. The farmers do that. There are 195 varieties of chickens now that man has created. Some give more eggs, some give more meat, some can stand colder weather, some can stand drier climates, but they're still a chicken. They've never been able, with all the farmers that are working on this full-time, trying to make money off of this, they've never been able to go to a non-chicken. So if you mean microevolution, variations within what is obviously the same kind, I'll concede that happens. Everything else beyond that, macroevolution, cosmic, chemical, stellar, organic, doesn't happen. It's never been observed. It's not part of science. So what would prove evolution? If he defines the word more clearly, I'll answer the question more clearly. But if they want me to believe that an amoeba and a hamster and a whale are related, I'm going to have to see some scientific evidence before I believe that. All we've ever seen is whales make baby whales. I used to raise hamsters. They had baby hamsters every time. No exceptions. So if he means macroevolution, I'm going to say that's a religion. That's not part of science. So what would prove that? Nothing has ever proved it. I don't think it's even a good theory, let alone a science.
Okay. And Jordan, would you like a quick response to that?
Like I said, all the time, I'm not a biologist. So if you want to learn about evolution, I'm not the guy to talk to. But simply put, this line between micro and macro evolution, nature is fuzzier than that. Nature doesn't care about our own definitions. All that evolution requires is differential reproduction with some errors, with some changes. Parents, maybe children are the same species as their parents, but they are different. And eventually, over time, those differences can add up. But again, not a biologist, hashtag. So.
I appreciate it. And Kent, since it was your question, you can have the last word.
I completely agree. There are variations and changes within, when animals reproduce, they might get a bigger chicken or smaller chicken, but they're always going to be a chicken. Those changes, they never add up to what they think. They claim this changes to a new kind. That's never been observed. It's not part of science. And if you get one animal that changes to something else, who's it going to marry? You got to get two to change at the same time of the opposite sex in the same place, and it's a really big world. And then all the rest of them have to die in order for this to work, or else that change is going to be blended back in. That's what all the dog breeders do. They're very careful to not let them breed back to the population because they would all go back to a mutt. They just try to be careful that their Chihuahua only gets a Chihuahua girlfriend because they want to keep it being a Chihuahua. So it's just simply not science to believe in any macroevolution. Okay.
Okay, thank you. Next question is from Nephilim Free, your best friend there, Jordan. Question for Jordan. If the Earth is millions of years old, why haven't the oil reservoirs lost their pressure through fissures over so many millions of years when we see so much geological activity everywhere? Go ahead, Jordan.
So I'm not a geologist, or they're actually specifically petroleum engineers. So they'd probably be a better one to ask than me. But there's a lot. I don't know how to answer that question because it's well outside of my field of expertise. You'd need, in order to demonstrate that is in fact a problem, you would have to demonstrate that there's a mechanism for this pressure to be lost, that there's no mechanism for it to be gained again later. You'd have to demonstrate that this loss of pressure, the differential, is such that it couldn't maintain it over a certain period of time. Like, there's a lot of math you'd have to do to demonstrate that. Just saying it loses pressure, therefore the Earth's young, is not enough.
I appreciate it. And I'm not sure if you wanted a quick response, Kent.
Yeah. I'm trying to quickly find my slides. I have 1,290 slides in that one presentation. I can't find it quickly, but I think I lived in East Texas for 5 years in Longview, and there's certainly lots of oil wells in the world. Oftentimes they drill down, they hit extremely high pressure, and the oil squirts out and destroys the well and everything else. There's no question oil is under incredible pressure. So the question would be, how did the pressure come from, and how could the Earth hold that much pressure for billions of years? And I think it's an impossible question for them to answer. The obvious question is the Earth would have cracked, the pressure would have found a way out. I mean, if I found a tire on a Model T that was still pumped up, and then somebody said that's been sitting in the barn for 90 years, and nobody added pressure to the tire, I'd have a hard time believing that. It's going to leak through the rubber. It's going to find a way out of there. I just don't think it's going to be logical to say the oil could be down in the ground for billions of years and not lose all of its pressure. So Jordan danced around that a little bit and said, you got to prove some way it can't be added. How are you going to add this pressure? Where's the oil come from to begin with? And how did it get down there? See, the flood answers all that for me. There was a flood, buried all kinds of stuff. They can make oil in the laboratory in 20 minutes. Not hard to make oil. Heat and pressure changes organic material to oil. There's a turkey farms where they take the turkey guts and squeeze it to oil and sell it. Common to make oil out of all kinds of stuff. So I think the flood did all that.
Thank you for the response, Kent. And Jordan, did you have a quick final word to that one?
If you want to learn about how oil pressure works, talk to a petroleum engineer, not a nuclear engineer.
All righty, here we go. So we got a question for you, Kent. Question from Andrew Cumming. Thank you for your question, Andrew. Question for Kent. What does expansion mean to you in cosmology? You must be referring to the Big Bang that you guys talked about at the beginning of the discussion.
Well, expansion obviously means to expand, to get bigger, to get further apart. We see the stars producing a red shift. This is assumed to be from the Doppler effect. I think it's a very reasonable assumption. I don't know any other explanation. That doesn't mean there isn't one, but I don't think anybody's come up with an explanation. If a train is coming toward you, it squeezes the sound waves closer and it makes the pitch higher. When the train goes past you, it stretches them or refracts them and makes the pitch lower. So you hear it. That's the Doppler effect. This theory is that if an object producing light is moving toward you, it will squeeze the light waves and produce a blue shift. If it's receding, it'll produce a red shift. I don't know of another explanation. I think that's probably correct. So they observe all around the universe, everywhere they look, there's a red shift. Okay, so that means probably the stars are moving away. I think that's a reasonable conclusion. And that's where you got to stop. The evolutionist or the Jordan would say that proves they all came from one spot. No, it doesn't. It proves they're moving away. They might have started last week moving away. The universe is expanding. I think it is expanding. I don't argue with that, but it doesn't prove billions of years. You have to start with, if you're going to add billions of years, now you got to start with the assumption that this expansion all started from here. And no, we don't know that. I think it's expanding. I think God created the heaven and the earth, and he stretched out the heavens, just like he said. But again, I'm not demanding everybody pay for my religious belief to be taught. They're demanding for theirs to be taught. That ought to stop.
Thank you for that response. Kent, Jordan, if you had a response, go ahead.
So it's more than just the fact that there's redshift. That was one of the first observations, but there's more observations that mesh that are independent. The cosmic microwave background is one of them. But it's also a prediction of general relativity, which we can observe that theory working very well in other situations. So when you have multiple sources, including extremely well-supported theories, making predictions, and all of them mesh together, that gives you a high degree of confidence. That's why we don't think that it started stretching yesterday or last week or whatever.
All right. Thanks for that response, Jordan. And since it was your question, Kent, if you had a final word, go ahead.
I have a much longer answer people can watch. They can get my DVD number 7, question answer, where I cover 5 hours worth of commonly asked questions in my seminars. The whole series is $50. They can watch it, copy it, send it back, get your money back. I'm not trying to get your money, but I'm not going to loan it to you. I got to pay to make it. But part 7 has a long answer to the starlight question. How did the stars get there? What about the red shift? And all this kind of stuff is talked about on my video number 7. So please watch that.
Okay, I appreciate it. We've got a minute here, just enough time for one last super chat. 2 last super chats. This one on the screen wasn't a question, just a fan of yours, Kent. Thank you for the super chat, $10 from Joshua. It says, "What's up, everyone? I'm just getting here. Thank you very much at Dr. Ken Hovind. Your life's work has truly been a blessing. Keep them coming. Great job at SFT. I appreciate it, Josh. Thank you for hosting the show. God bless. God bless you too, Josh. I appreciate the support." So we'll end it with this super chat from Jamie Russell. Not specified to anybody, but I believe it's you, Jordan. Question is, the Oklo mine. How come it only happened 2 billion years ago? What kickstarted it? And why did it not start sooner?
I am so excited that this question got asked. Okay, so okay, so the way that a nuclear reactor works is you have to have enriched uranium, and it has to be in the presence of water. That's because the water will slow down the neutrons that are produced by fission, so they can be absorbed by new neutrons and make more fission. That's how a nuclear reactor works. The nuclear reactor that produces your energy works the same way. You have to have uranium at a certain enrichment. Otherwise, the physics don't work out because the uranium won't absorb the neutrons very well. So the physics demand that you have 3% enriched uranium or more. We usually use about 5, and water to slow the neutrons down in a light water reactor. So the reason it didn't happen before 2 billion years ago is because uranium right now, if you just dig it out of the ground, is only 0.7% enriched. It's becoming less enriched over time, which means it was more enriched in the past. So if you do the math, you can look back at my slides. I showed it. If you contact me on my Facebook page, I'd be happy to give you all the math and go into. I will talk to you for hours about this, but that's why, because that's how long it would take for it to decay.
All right, I appreciate that. And Kent, if you had a quick response to that.
No, he had several obvious assumptions in his declaration there. That where did the uranium come from? How did it get enriched to begin with? And Where did the water come from? And we know the decay rate's always been the same. Those are the same obvious assumptions in all of these things.
All right. So that brings us to an hour and 35 minutes. I got to say it's flown by. Thank you for the questions, super chats, everybody. Great debate. Thanks for keeping it respectful and cordial. Ken and Jordan, definitely a good debate. Very engaging. Any final words before we close it down for the night? First, I want to thank you guys again for giving us your time for this debate. So any closing words? Dr. Hovind, you can start.
Well, sure. I'd like to invite everybody to come visit Dinosaur Adventureland. It's free. Jordan, come on down. We'll give you a tour, give you the real tour on the four-wheeler, show you around the place. We got all kinds of cool science experiments in our science center where we teach God made the world. We have all kinds of chickens and different kinds of goats, and they had common ancestor called a goat, and the chickens had a common ancestor called a chicken. But we have a great time here, visitors coming from all over the world to see this place. So we'd love to have everybody come. It's free, drdino.com, our website, and our YouTube channel we do every night. Normally, we'll post this on our YouTube channel later, Kent Hovind Official. So look there, subscribe, and join us. Come visit and pray for us. We want to win the whole world to Christ. Jordan, we want to win you back. You're going to make a great evangelist once we get you straightened out.
Awesome. Thank you for those concluding words, Kent. And Jordan, go ahead. Some final thoughts.
Well, I wanted to thank Dr. Hovind for coming. I know he's a very busy man, and it was just as fun this time talking to him as last time. It was a blast. And I promise you, if I'm ever down in your neck of the woods, I'll drop by.
Okay.
If you guys enjoyed this conversation, we run a podcast. We run an episode every month. It's on general skepticism, so we do talk about religion quite a bit because we're both atheists. The person who does it with me used to be a theologian. So we talk about things like the historicity of the Gospels, but we also talk about alien abductions and anti-vaxxers and any other topic you want us to talk about. So you can find us on our Facebook page. We have a YouTube channel, Reason the Number 2 Doubt, and also wherever podcasts are sold, iTunes, et cetera, et cetera. So, yeah.
Awesome. Okay. Well, thank you for the final words there, gentlemen. Thanks again for a great debate. Thank you to the audience, very lively audience. We'll see you guys again tomorrow. We've got a debate at 8 o'clock. Another exciting one on whether or not Noah's Ark has been found. So we'll see you guys tomorrow for 8 o'clock, and SFT is out.
All right. Thank you. Yay.